This is the probability density rho psi star psi. I have differentiated it by u into v form. So the derivative of this into that plus psi star into derivative of other one. This is equation number 1. Then I have written Schrodinger equation, that is h psi is equal to E psi. H is the total energy, which is the kinetic energy plus the potential energy. This is the potential energy, which is function of position r, since we are working in 3 dimension, and del square is same delta 2 over delta x2 but in 3 dimension, and that is I have written for p square over 2m is there, and p square I have written its operator, which is minus h bar square del square, and this is equal to E psi. This is the operator for energy, which is I h bar delta over delta t, and I think 2-3 lectures before we have already talked about that. Or you leave this there and bring I h bar there, so it is 1 over I h bar, this whole thing. And similarly, if you want to find it for its complex conjugate, put star it there. This will be replaced by minus I, minus h bar square over 2m, del square psi will remain this, but this will be psi star, and this will be v star. But since potential energy is always real, so they are the same, okay, and then psi star. Then what I did, I have substituted this there, and I have substituted that there, that is substituting equation 2 and 3 in equation number 1, and what will happen, these 2 terms will be cancelled out because they are the same, because VR is V, and you will be having only these 2 terms. So these 2 terms are there, and h bar square over 2m is common out of that. Now, then what I have done, h bar over 2im, and that is written with the help of Green's identity. Just go and look into your book on probability current, how it is done. It's very simple. It is very simple, and you should be able to get this step from this one by making use of your vector analysis. So delta rho over delta t is that. Then this quantity which I have, bounded in curve, that is denoted by symbol S. Okay, so S is a vector because this is vector multiplied by scalar, this is vector because it is gradient of psi and gradient of psi star, both are vector, one vector minus other vector, so hence S is vector, and S star is this thing without minus sign, without del, is denoted by symbol S. And if you denote it by symbol S, then this is delta rho over delta t, and then bring this to that side, plus del dot S, and that is the equation of continuity. You have seen it in electricity magnetism, you have seen it in classical mechanics and hydrodynamics, etc. And I'll explain it in a moment. And this can further be written as this one, because if you take conjugate of this, then if you take conjugate of this quantity, then this star will disappear, but star will appear here, so it means it is complex conjugate of that. Now suppose that you have one complex number Z1, which is x plus iy, x1 plus y1. Then you say, okay, you have its complex conjugate, that is, this is complex number, that is its complex conjugate, that is equal to, so okay, let me remove 1, okay. So it is Z is equal to x plus iy, and Z star is x minus iy. Now what I do, I just cancel it, these two will cancel, and this is Z minus Z star is equal to 2iy. What does it mean? If you subtract conjugate of a complex number from the complex number, the answer is 2 times imaginary part of complex number. And this, what I have done exactly, since this is complex conjugate of this one, so I have written it as 2 times, okay, 2 times I and that thing. But since it is imaginary means I is there, so I have removed I, and 2 is cancelled with that, and that is I is gone, because that I and I will cancel out, and that is gone. It is the imaginary part of that. So either you use this equation for a probability current, or you use this expression for probability current. This represents probability current. What it says, if you look at this equation of continuity, and in fact it says that delta rho over delta t is equal to minus del dot s. That is, the change in probability density with time is equal to negative divergence of the probability current. Okay? Rate of change of probability density with time is equal to negative divergence of probability current. Okay? Now look what it says. Suppose that there is some small insect, it's come into a room, and you divide that room into small volume element, then it is moving thing, since particles are also moving, so it moves from one volume element to another one. So there is degrees in probability density, there is a change in probability density in one, but there is increase in the other one, because it flows to the other volume element. So this is why that is the equation of continuity, and this is very important concept as far as quantum mechanics is concerned. It gives you the probability current, that is how particle move from one place to another, and what is the equation working behind them. Now we'll make use of this in some problem. Now problem is, suppose you have a potential step problem. Last time I gave it to you for your own study. This is x is equal to 0, and that is infinity, minus infinity, that is Vx, potential. Now, potential is constant in this region too, and here potential is 0, V is equal to 0, and V is equal to V naught. So, the Schrodinger equation in the two regions are d2 psi over dx2 in one dimension plus 2m over h bar square E minus V psi is equal to 0, and in region 1 you have d2 psi over dx2 plus 2m over h bar square E psi is equal to 0, because here in region 1 V is equal to 0, so no problem. And this is further written as d2 psi over dx2 plus k naught square psi is equal to 0, and k naught is 2m E over h bar. 2me square root over h bar. Similarly, in region 2 you have, so this is your psi 1. In region 2 you have d2 psi 2 over dx2 plus 2m over h bar square E minus V naught, because in the region 2 V is V naught, psi is equal to 0, or d2 psi over dx2 plus k square psi, this is not psi, it is psi 2, is equal to 0, where k is equal to 2m e minus v naught over h bar. Okay, so these are the wave number. You solve this equation. If you solve this one, your solution is psi 1 is equal to a e raised per I k naught x plus b e raised per minus I k naught x. And if you solve the other one, this one, then psi 2 will be equal to c e raised per I k x plus d e raised per minus I k x. Both of them are second order differential equation, so they have two linearly independent solution, and their linear combination is also the solution. Look at that. That's mathematics. But physically, if particles are going from here to there, then this represents incident wave going in the positive x direction with this amplitude, and this represents reflected wave in the same region. So this is a e raised per I k naught x, and this is b e raised per minus I k naught x. So as far as the physical situation is concerned, this equation is okay. Then this represents a wave with amplitude c going in positive x direction. So this is the wave which is transmitted, and that is c e raised per I k x. And since there is no particle coming from reflection from this side, therefore this solution is not physical. Of course, mathematically it is okay, but it is not physical because our condition is that particles are moving from the left, not from the right, and hence these are the things. Now, I ask you a question. Okay, find probability current number 1 of incident particle. Or probability of incident particle. Number 2 of reflected particle. And number 3 of transmitted particle. Three parts. What you will do? You will be making use of this relation or this relation. First, you will be using incident particle wave function is that. So for this, you will be using this as psi. You will say it is psi incident. So what you will do, the incident, you will write S incident is equal to h bar over m, imaginary part, psi star, take it psi star, which will be a star e raised per minus I k naught x, right, del into del of psi, that is a e raised per I k naught x. Now del means delta over delta x. Calculate that. Okay, so it is h bar over m, imaginary part of, since amplitude is real and therefore it is a square, and that is derivative of this will be, well, this will remain as it is, e raised to minus I k naught x, and derivative of this is e raised per I k naught x into I k naught. Now this will cancel with that one, and you will be having h bar over m, imaginary part of a square I k naught. Since this is the imaginary part, because I is there, and therefore your answer is h bar over m k naught into a square. That is your incident probability current. Similarly, you calculate the reflected probability current by making use of this, that is psi reflected, and then this is psi transmitted. Okay, you find that this is psi transmitted, and let me know what answer you get. Okay, I'll discuss little bit physics based on this in later stage. Okay, that was one portion of the things today's agenda. Now we come to some other thing. And you can do it for every problem. You can do it, you can find it, probability current in 3 regions. For, potential barrier problem, potential well problem, and whatever problem of that kind. Now I come to some very basic problems based on the concepts, the postulates which we have covered so far. The first problem is on page 136. Page 136, it is solved problem. Solved. And it is problem 2.4. 2.4 page is given, and it says, consider a state. Now listen very carefully, because I don't want to write it. You just study the book and you will find it. Consider a state, and I am using the bracket notation which we have discussed last time. Psi is equal to, consider a state, 1 over square root of 3 psi 1 plus 1 over square root of 3 psi 2. Consider a state of the system plus 1 over 10 square root psi 3. Consider a state psi of a particle which is equal to 1 over square root of 3 times psi 1, 1 over square root of 3 times psi 2, and 1 over square root of 10 psi 3, which is given in the form of 3 orthonormal. They are orthonormal. Orthonormal. Which is given in terms of 3 orthonormal eigenstates, psi 1, psi 2, psi 3, of an operator B, of operator B. These are 3 orthonormal states of an operator B such that B operating on psi n gives you n square psi n. Find expectation value of B. Find expectation value of B for the state psi. Now let me explain. First the problem. Look, you have studied one of the postulates of quantum mechanics, if psi 1, psi 2, psi 3, psi 4, psi 5 are state of a system, then their linear combination is also the state. So this is also the state. Then he says that these are orthonormal. Orthonormal mean that psi n, psi m d tau minus infinity to plus infinity, and this is equal to 0 when m is not equal to n and equal to 1 when m is equal to n. Okay, when wave functions satisfy this equation, it means that they are normalized, at the same time they are orthogonal. And when they are normalized and orthogonal, then they are known as orthonormal. They are known as orthonormal. So it means that they are orthonormal. It means that you take any two of them, take psi 1 and psi 2, so m is not equal to n, integrate, result will be 0. And if you take psi 1 and psi 1, answer will be 1. Psi 2 and psi 2, answer will be 1. Psi 3 and psi 3, answer will be 1. But psi 1 and psi 2, answer is 0. Psi 2 and psi 1, answer is 0. Psi 2 and psi 3, answer is 0. Psi 1 and psi 3 is 0. Psi 2 and psi 3 is 0, etc., etc. And further, if B operates on any one of them, then it is, if suppose it operates on psi 1, then look, it means that it is 1 square mean 1, and eigenvalue will be 1 for B. If it operates on this one, then this will be 4 psi 2, and operate on this one 9. Okay, and he is saying, okay, find the expectation value for the state psi. Okay, so let's find the expectation value. Furthermore, we will be, देखें, expectation value of a dynamical quantity is given by, this is the dynamical operator, but if psi is normalized, then this is 1 and expectation value is just equal to that one. But if it is not normalized, then it is, you have to divide it. We don't know whether psi is normalized or not, so let's first find this integral. And if you find this integral, psi is equal to, that is, multiply it by its bra, so that is done. So it will be 1 over 3, and then again multiplied with that, psi 1, then you multiply psi 1 with, because if you write its complex conjugate, it will be like this, psi will be equal to 1 over square root of 3 psi 1 plus 1 over square root of 3 psi 2 plus 1 over square root of 10 psi 3. So you multiply it. So this will be multiplied with all the 3. This will be multiplied with all the 3. This will be multiplied with all the 3. You will be having 9 expressions. Okay, so 1 over 3 psi 1 psi 2 plus 1 over 3 1 over 10 psi 1 psi 3. So I have multiplied this 1 with all the 3. Then I am going to multiply this with all the 3. So it will be 1 over square root of 3, 1 over square root of 3 psi 2 psi 1 plus 1 over square root of 3 1 over square root of 3 psi 2 psi 2 plus 1 over square root of 3 1 over square root of 10 psi 2 psi 3, and similarly the last one 1 over 10 into 1 over 3 psi 3 psi 1 1 over 10 1 over square root of 3 psi 3 psi 2 plus 1 over 10 square root 1 over 3 square root psi 3 psi 3. But we are given that is, this is ortho normal set, which I explained when m is not equal to n, it is 0. So m is not equal to n, this is 0. M is not equal to n, this is 0, because this represents integral psi 1 psi 2 d tau. It represents that thing. So that is 0. But this will be 1. This is 0. But this is 1. This is 0. This is 0. This is 0. This is 1. And answer is 1 over 3. 1 over 3 is 1 over 3. Square root will disappear. Here 1 over 3, 1 over 3, square root disappear, plus 30, 1 over 30, square root, and this is 1, and you just simplify it and you get the answer is the following. Answer is okay, I am sorry, because this is 1 over 10, 1 over, and this will be 1 over 10. Okay? So this is 1 over 10 mean it is 1 over 10. And if you simplify it, then you will be having 30 and 10 here plus 10 here plus 3 here. ये मैंने ठीक किया? अच्छा. So 1 over 3 6. Sorry, 3. 1 plus 1. 2 over 3 plus 10. 1 over 10. 30. Base plus 3. Yes, 23 over 30. So that is the answer. That is the normalization constant. So this result is 23 over that one. Okay. Now, maybe I have made some mistake somewhere, but that is the procedure. But in the book, I don't get this answer. I am getting different answer. Okay. So remember one thing. Maybe because of my eyesight, I have written some number wrongly. Okay. This is what we have done. It means that it was not normalized. Its value is 23 over, its value is how much? 23 over 30. All right. Now you calculate that one. Now you calculate the other one.